Today we will talk about the mesh current analysis in the case of there are the current and voltage source. In the viewpoint of the mesh equations, we need to know about the mesh current. At first we'll define the mesh current. Then based on that values, we will recalculate every current or voltage and current. So to approach the circuit analysis based on the mesh current, we should know the mesh current in every circuit. Well, in this viewpoint of that, if there are current source, that means these source give us a very good point to get the mesh current. For example, because there are one current source here, and we define this is mesh current I1 and this I2, then that current source IS give us a good point that minus I1 plus I2. So without any analysis, we can get the point here. So we should use that characteristic of the current source in the viewpoint of the mesh current analysis. Okay. So to analyze these equations, these circuits, viewpoint of the mesh. So we should first we should do the element. They define the element, the voltage here. So I will rewrite the voltage here. We'll define this as a V1 and this is a V2. And we'll define that value is VAB. And we'll define this as the V3. And we define the current mesh, this is mesh 1. So this is I1, mesh current 1. We define the second mesh here. We define this current is I2. So what is element voltage here? Because right here is what is V1? V1 is R1 and current here is only I1. So there will be R1 and I1. And what is V2? There will be the R2 and current here is only I2. So there will be R2 and I2. And what is the V3? The V3 is a resistor here. So only current flowing through R3 is I2, the mesh current. So there will be R3 and I3. Oh, excuse me, this is not 3. This is 2. Then, but we don't know what is a VAB. I don't know. Why? Because that is a current source voltage. So in this case, we should use the characteristic of the current source. Even though the VAB cannot be calculated based on the Ohm's law, but this source give a very good hint. What is that? IS is I2 minus I1. We should use it here. Okay, first we define the element voltage, and second step is we make a mesh equation by KVL because we define the two meshes here. So first the mesh here, mesh 1 is that we will start with this here. We will start here. We met first Vs. So Vs we met minus with y. We met minus Vs, and we met the V1 and plus V1. So this is V1, and we met the VAB plus VAB will be 0. So here we got the Vs is V1 plus VAB is R1 I1 plus VAB. The R1 is come from here. And we will make a second mesh equation, mesh 2. here we will start here. So we stay here. We met what? VAB, but the direction is minus, so we can write minus VAB. And we go up and we met what? V2 and plus V2, so we write plus V2. And we met what? V3 and plus V3, so we can write plus V3. And we met in this start point, so there will be 0. So we insert V2 here and V3 here. So VAB will be V2 plus V3. There will be out I2 plus R3 I2. So that is equation here and here. How many unknown variables are there? We have 3 unknown variables. What? Vs I1. I'm sorry. We Vs is given values VAB and I1 and I2. So we have 2 equations, but we have 3 unknown variables. Right? VAB and I1 and IB. So we need one more equation. How do we get that? That is from the here. So we have 3 equations and 3 unknown variable. Based on here, we can get calculate here. So, well, in this case, we're using that. So we insert the here, equation here. So we reading the here. So what is VAB? VAB is that values. So we rewrite R1 I1 plus VAB here, R2 plus R3 I2 will be VS. And here, what is a V2? V2 is IS plus I1. So we adding that value here. So we add here. So R1 I1 plus R2 plus R3 IS plus I1 will be VS. So R1 plus R2 plus R3 I1 plus R2 plus R3 IS will be VS. Based on here, I1 will be VS minus R2 plus, oh, excuse me, this is not 2, those are 3. R3 IS divided by R1 plus R2 plus R3. So in this way, we can get the I1 investment here. So using here, we add here, so we can get the V1. Based on that equation, so we calculate I2 here. So we adding I2 here, so we can calculate V2. And the same way, we can get the V3. In the same way, we can calculate VAB also. So that's a way how to solve the mesh current analysis when the circuit has the independent current source here. So this is an example as a 4 and 6-1. That circuit is like here. So I mean, it looks like there are 3 mesh current here. There are 3 mesh. Here is first I1, and second, and third I1. And we can define in the problem the resistance is given here 1, This is 1 and this is 2. So to find the 3 mesh current, so what should we do? The first, we should define the element voltage here. So I choose define their voltage is V1 and their voltage is the V2, and we define their voltage is the V3. And I would like to define that voltage VAB the same way, because the node is A and B. So first I would like to define the element voltage here. And what is V1? V1. In the current here, R1 is belong to the mesh, the first mesh and also second mesh. So current here in this way is I2 minus I1. So V1 is R1 and I2 minus I1. And how about the V2? V2, R2 is belong to the first mesh here and also second mesh. So we define the positive direction of the voltage here plus. So V2 will be R2 and current going here way is I3 and minus I1. So I3 minus I1. And the last voltage here, V3. The V3 is the R3 is belong to only third mesh. So this is a little simple because it's R3 and I3. Okay, we define the element voltage here. Then what is the next step? We should make mesh equation by KVL. So we have 3 mesh, but why we make a mesh equation? The reason to make a mesh equation is to get the mesh current. But in this case, in the first mesh here, I1 is defined by this current source. This is a very good thing. Without any calculation, we get the I1 is 4 because there will be 4 ampere here. So we don't need to make a first mesh, the mesh equation. So from first mesh, we get I1 is 4. Then second mesh here. So we will start mesh here. So we start here. At first we met 10 volt to the minus. So we can write minus 10. And we met the positive V1. So we can write plus V1. And we can make a positive VAB. So plus VAB. And we made a start point. So that will be done. Is 0. So from here we can calculate the V1 plus VAB will be 10. And what is a V1? V1 here. So we insert here. So their value is R1 I2 minus I1 plus VAB will be 10. There's the first mesh equation. Then we will do that in the same thing in the mesh 3. So we will start here. Then we met VAB at first, but in the point of the minus direction. So we can write here is minus VAB. Then we met what? The V2. So there will be V2 here. Then we met the V3, the plus. So we can write the V3 here is 0. So we're adding the V1, V2 and V3 here. So V2 is I2, I3 minus I1 plus V3 is I3 and I3 will be VAB. So based on that, we have we have three unknown variables. What is that? I1, I2, I3, and we want more unknown variable because of the current source, VAB. Based on the first loop, we know that value is 4. And we have three unknown variables, but we have only two equations. So we need one more equation. How to get that? That is based on the voltage and current source here. Because of that, we can define the 5 is what equation? I2 minus I3. So we have one more equation here. So based on that, we can do that. The VAB and VAB is the same things, so we can rewrite this equation is VAB is 10 minus R1 I2 minus I1, and here VAB is I2 I3 minus I1, and R3 I3, because this is the same thing. So 10 minus R1 is 1, so I2 plus I1, R2 is 1, so I3 minus I1 plus 2 I3. So I1 is 4, so 10 is 4, so 14 minus 2 is I3 minus 4 plus 2I3. So I3 will be 18 minus 3 I3. Oh, I'm sorry, along here 3 I3 plus I2 will be 18. And we got here minus I3 plus I2 will be 5. So we minus, then 4 I3 will be here. So I3 here, I2 is and filters. So based on that, we get I1 is 4, and we can get I2 and I3 here. That's a way how to solve the circuit using the mesh current analysis. The circuit when the circuit has a current and voltage source. We have using the super mesh. In the case of the node analysis, when node has a the voltage source, and we should use no super node. That is a very simple way to get the equations between two node voltages. But in the case of the mesh current analysis, as you see here, because even though they have the current source, they don't use the super mesh. In the case of the mesh current analysis, without the super mesh, you can make mesh equations and solve the variables. But in the case of the current source is in among the two meshes here. In this case, the current source is connected to here, where that is connected. That current source belong to the only one mesh. Then will be a simple problem. But in this case, the current source is belong to the two meshes. Here, this mesh and this mesh, and that is connected by other element in this like here. Then it's more complicated. Then we can use the super mesh here. This is not only way to solve this electric circuit based on the mesh equation, But if you're using the super mesh here, then the problem will be a little, the problem is very simple. So we can define the super mesh. What is a super mesh? The super mesh is one larger mesh that created from the two meshes that have the independent or the dependent current source in common. So there are one common, the current source here. We have the three meshes here, 1 and 2 and 3 here. But the source belong to the first mesh and second mesh. Then we can make a super mesh here, not going path to the current source. We can make a mesh here. So we call that is a super mesh. So I want to give you the example of that. So in this case, we can make a mesh current here. So because of this current source, you cannot define the element voltage here. So at first, I'd like to make element voltage here. I would like this is a V1, and this is the V2, and this is a V3, and this is the V4. So, and I will use a super mesh here at first, here. Then mesh 1 and 2. This super mesh. I will start here and go up. I met 10 volt and minus. So minus 10. And I met what? V1. I met V1. And I met V2. And I met V4. And I met start point. So there will be 0. Oh, we missed something, but what should we do before make a mesh equation? We should define the element voltage first. Then I will try that. What is a V1? V1 is voltage here. That is 1 ohm. And current is, this is I1, this is I1, and this is I3. So 1 and I1 minus I3. And what is a V2? V2 is 3 ohm. And this condition is I2, and this is I3. I2 minus I3. And what is V3? There are only one current here, I3. So 2 I3. And how about V4? V4 is similar. V4 are 2 ohm. This resistor belongs to only the second mesh. So there will be 2 and I2. So we can insert here. Then we can get minus 10 plus V1 is I1 minus I3, and V2 is plus 3I2 minus 3I3, and V4 is plus 2I, this is 2, I2 will be 0. And we can make it simply, that is I1 and plus 5I2 minus 4I3 will be 10. And I'd like to make a second mesh here, mesh 3. Then how about this? We start here. I'm still here, and I met what? Minus V1. So minus V1, and we met plus V3. So plus V3, and we met minus V2. So there will be minus V2 will be 0. And we insert the variable here. So what is minus V1? What is the minus V1? V1 is minus I1 minus I3 and V3 is here, plus 2i3 minus 3i2 minus 3i3 will be 0. Based on that, minus i1 plus i3 plus 2i3 minus 3i2 plus 3i3 will be 0. So we can simplify the equation minus i1 and minus 3i2 plus 6i3 will be in 0. And we have three unknown variables. What is that? I1, I2, and I3. How many equations we have? We have 1 and 2. So because we have three unknown variables, but we have only two equations, so we need one more equations to solve this problem. Where is the equation? There's in the supernode. Because here, current source, we can make a relationship between the mesh current 1 and mesh current 2. So based on here, mesh current 1 minus I2 will be 5. So finally, we got the third equation here. So using three unknown variables and three equations, based on we can calculate the I1 7.5, I2 2.5, I3 is 2.5. So to get the V1, actually we know the mesh current is kind of just mesh current. These are kind of the component, the variables to describe the electric circuit here. So the values of this circuit is the V1, not I1. So to get the V1, we insert that current here. So we can get the V1 and V2 and V3 and V4. And what is the current going through this resistor? That will be I2 minus I3. Based on the mesh current, we should recalculate the current of the voltage of each element. As you know, the mesh current is kind of a technique to solve the electric circuit. That means to get the voltage or current of each element here. So next is an example of 6.4.6. The example is for the point 4.6 and 2. We should define the mesh current 1, I1 and I2 here. This is a simple way. So what should we do? What should we do? At first, we need to make a mesh. We need to make a mesh here. So that is a mesh 1, and there is a mesh 2. Then there are the current source here. So at first, we will solve this problem using the general mesh equation here. Now, what should we do? At first, we have to make first element voltage. So I would like to define here that will be V1 and there will be V2 and there will be the V3 and there will be VAB here. So what is V1? V1 is, because this 9, this is only one mesh current here, I1, 9, I1. And what is V2? There only one current is I2, it's a 3, I2. And what is V3? It's 6, I2 here. And there are one more unknown variables. What is that? VAB, but I don't know what is the value because there is a voltage between the constant voltage source here. Okay, then next is we make a mesh equation. Here. So first mesh 1. then that will be mesh 1. We'll use. So we will start here. At first I met that, how much is it? That will be minus 12. And I met plus V1. So plus V1. And I met plus VAB. So plus VAB. And I met a starting point. So that will be 0. Then second mesh. So we start here. I start here. I met first voltage minus VAB. So minus VAB. And I go to I met plus V2. So plus V2. And I met the plus V3. So plus V3. And I met starting point. Then there will be 0. So we reuse that element voltage here, adding here. So we can rewrite these mesh equations. Then minus 12 plus 9I1 plus VAB will be 0. And minus VAB, V2 is plus 3I2 plus V3 is 6I2 will be 0. How many unknown variables here? There are 3 unknown variables. What is that? I1, I2, and VAB. But we have only 2 equations. So we need more equations. How to get that? That is based on the current source here. So we get, this is 1.5, this is I1, this is I2. So 1.5 will be I1 minus I2. So we have the third equation. So we have 1, 2, 3 unknown variables. We have 1, 2, 3 equations. Based on 3 equations, we can get a solution about I1 and I2. So there is a way to get the based on here. We can calculate I1 will be, I2 will be minus 0.5 over 6. That's your very general solution to get that. But we have another way to solve this electric circuit using the mesh current. The second way is the super mesh equation. It will be more simple. We can make a super current here, super mesh here, in this way here. Why? There are 2 mesh, but the current source is common here. So we rewrite this mesh and we can make a mesh equation here. It's very simple. We will start here, okay? I will start here and I met first minus 12 and we met here. What is that? The same way, because this recently this is V1. We already do that in this equation. The same node voltage. V2, this is a V3, V1 is 9I1, V2 is 3I2, V3 is 6I2, that's way. So we met plus V1 and we met plus V2 and we met plus V3 and we met starting point. So there will be 0. So we adding this multiplication in here. So minus 12 plus 9I1 plus 3I2 plus 6I2 will be 0. We have only one equations. but we have only two unknown variables, I1 and I2. We need a more equation. How to get there? The same way, because there are one current source here, so 1.5 will be I1 and I2 minus I2. We have other equations. So using two equations, and we have only two unknown variables, I1 and I2, we can have simple calculation, the same result with the previous result. What is the more simple? Actually, they are the same things. It's not different actually, because the mesh equation is very simple. The mesh is very common. So, and whatever you do, it's your choice. It's your choice. It depending on you. Okay. There is another chapter. Is mesh current analysis. In the case of the circuit has a not independent source, but the dependent source. The control current or voltage of the dependent source must be expressed as a function of the mesh current. That's a way how to solve the electric circuit with and having the dependent source. They're using the mesh current analysis. The technique of the mesh current analysis is the starting point. The idea of mesh current analysis is all variable voltage or current should be written with the mesh current, the redefined mesh current. So even though there are the dependent source, the value of the dependent source should be written with the mesh current. Then the problem is the same things compare the previous ones we discussed before. Okay, I will give you an example. Is point 4 and second one. The problem is find the VM using the mesh current. As you see, the VM is a voltage of the current source, but the current source is a dependent current source here. So that value VM, the current over here is proportional to the IA, the current going through here. This is 5 IA. So what should we do? We should, we have to written that value, the 5 IA should be written in the mesh current. So to solve this problem, at first we should define the mesh current here, because there are two meshes. So we can rewrite the mesh current here. We rewrite this is I1, and we write here this is I2. So what should we do? IA will be I1 minus I2. So based on here, we can write that value will be written here. Then what is I2? That current is 5 IA is opposite value of the I2. This is minus I2, but IA is here, so we insert here. Then the 5 I1 minus I2 will be minus I2. So 5 I1 will be 4 I2. So I1 will be 4, 5 I2. That is the main key. Based on this dependent source. So then we define the mesh current in the same way. At first, I'd like the voltage here. This is a V1, and this is a V2, and VM is defined in this way. So what is the mesh one? Mesh current. Mesh equation 1. I'll start here. and I met minus, where's that? Minus 24, and I met plus V1, plus V1, and I met what? 0. So there will be 0. And what is V1? The V1 is here is current I1, and the V1 is 32 I1. And what is the V2? 32, and currently flowing this register is I2. So 32 and I2. I'm sorry, this is not I2. This is I1 and this is I2. And second mesh equation is, I will start here. I met first V2, so V2, and I met minus V, so there will be minus Vm, and I met starting point here, there will be 0. So I insert that value here, so we can, V1 is 24, the V1 is 32 I1. So, and here Vm is V2, and V2 is 32 and I2. So based on here, I1 will be 24, 32 is that value here. Based on here, we can calculate I2. Then I2 will be is that value when we insert here. So Vm will be 32, 3. So that's a way to calculate the Vm here. So Vm will be 3. So what is the different things compared to the previous one? Because there are current source, dependent source. At first, we redefine the value of the current source value based on the mesh current. Then we will start the same things. And first, we make elemental voltage here. And second, make a mesh equations. Then solve it. That's it. It's very simple. It's not different. Only thing is we have to redefine all the control variable of the dependent source. It would be the current source. It would be the voltage source. Okay, this is example of that. We can do that in a simple way. It's very simple. We find the voltage gain of A. This is the dependent current source here. The value of current source value is minus 7.2, but that will be given by the current here, and the gain is A. So we should know, we should define, and we should find the value of the gain of A. So what should we do? Because there is a kind of the dependent source, we should define that variable based on the mesh equation. So at first, I'd like to define the mesh. So I define this is I1 and define this is I2. Here we can define the IA. IA is control current of this dependent source. IA is this is I1, this is I2. So I1 minus I2. That means the voltage here is A I1 minus I2. Then what should we do? Then I'd like to define the voltage here. Elemental voltage is V1. This is the V2. Then where's the V1? V1 is 10. The current is only I1, so I1. And V2 is 4. And current is I2. Then we can write you can write a mesh equation here. The first mesh one. Okay, I will start here. I met minus 36, and I met plus v1. So we write plus v1, and I met a starting point that will be 0. The second mesh, I will start here, and I met plus v2, so v2, and I met plus minus 7.2. So we write plus minus 7.2, and we met here is 0. So we insert that value in here, that value in here. So we rewrite this equation is v1 is 10, I1 is 36, and v2 is 4, I2 is 7.2. From here, I1 is 3.6, and I2 will be 1.8. So based on here, we insert here IA is 3.6 minus 1.8 is 1.8. So what is that? IA is minus 7.2 will be 7.2. So gain A is 7.2, IA 1.8 will be 4. So A is 4. This is way. The unit of that is the output result is a voltage, but the input value is current ampere. So the gain of A, the unit of the gain A is voltage per amps here. So that's a way to solve. The simple way to get the electric circuit has the dependent source using mesh current analysis. This is the last chapter of the chapter 4. In chapter 4, we have studied about how to make equations to solve or analyze the electric circuit. We have, the way to get the information or the analysis results, or the elementary voltage or elementary current is a KCL and KVL. That's all. That's our only unique the law we have to use to analyze the electric circuit. But if the circuit is complicated, then we need to very difficult to analyze the circuit. So to approach simply to analyze the electric circuit, there are two techniques to solve the equation. To solve the electric circuit. That was node voltage method, and there was the node voltage method and the mesh current method. In node voltage method, we define the node voltage based on the reference node. In the case of the mesh current method, we define the mesh current and get the mesh current values. And based on node voltage or the mesh current, we rewrite the element voltage and current respectively. So it depends on you what kind of what method you use. It's your preference. It's the same result, even though all circuit has the same result, even though you use the node voltage method or the mesh current method. So in the rule of thumb, when the circuit has only voltage source, then mesh current method is more simple. Or if they are only current source, then node voltage method is a little simple. This example, the 4 and the 1, we should find the R, but in this circuit, there are only current source here. So we will do this using the node voltage method at first. What should we do? But anyway, we need to check it. How many voltage are node voltage here? I mean, if we use the node voltage Z, then how many things? It's a 4. In the case of mesh current, how many meshes here? This is a 3. Then, if we make a mesh here, like this is, we make a mesh here, this is a mesh here, then this is I1, then this is I2, and this is I3. Then based on that, we can calculate, I mean, we don't need to calculate that. I1 will be 1 because there is a current source, and I2 will be 3, and what is I3? I3 is given here, 0.5. So based on the mesh 3, we can choose what is mesh here. That's all. We make a mesh equation here. So we start here. Then I met first R is R I3 minus I2, and I made 2 I3 minus I1 because this is I1, this is I3, and 12 I3 because I3 here. So that will be 0. So that value considered here, then minus 2.5 R and 2 minus 0.5 plus 6 will be 0. 2.5 R will be 5, so R will be 2 ohm here. Then how about the node voltage method in this case? So we'll try that. R is 2, then we'll try that again. So what should we do at first? Node voltage method. What should we do? We should define the reference. I mean, we define the node. How many nodes here? 1 and 2 and 3 and 4. There are 4 nodes. I choose that node as a reference here, and this is A, B, C. So I'd like to make a node voltage method. Then this is a VA, VB, and VC. So in this case, we should make a node equation. Node A. What should we do? I mean, there are so many current here, so define current here. This is current I, A. This is current I no, I'm sorry. I will choose another notation here. I1, I2, this is I3. Then how about node A? Node A mean here plus 3, here minus 1, here minus I1 will be 0. How about node 2? Node B. I1 is coming here, so plus I1. I3 is going out, I3, and minus I2 will be 0. How about node C? Going into 1 amps, so plus 1, and I2 is coming. I2 and 0.5 is going out here. It will be 0. So what's that? I1 is 2. What's that? I2 is minus 0.5. And how about I3? I3 is I1 minus I2. It will be 2.5. So what can we calculate here? I mean, VC is 0.5, that's 12, so that value is 6 volt. So VC is a 6, and I2 is minus 0.5, so that value is 1, so this is 5. So VB is RI3, so VB is 5, so R is 5 divided by I3 is 5, 2.5 is 2 ohm. The same result in the case of the mesh current method. So it depending on you, what should we do? What would be, I mean, what do you use any math technique? But the result is the same. This is another example. This indicates there are mixed the voltage source and current source. So we should know the R. So in this case, I will choose the mesh current method here. So, and then in this case, I will choose the node method, node voltage method here. So this is, first we need to analyze the circuit, the 2 ohms here and 2 ohms here, 12 volt and 16 volt and 2 ampere independent current source. This is our values, and the voltage here is 16 is defined here. Then at first I'd like to define a node here, and here, and here, and here. So I'd like to choose the reference node, and this is A, and this is a B, and this is a C. So this is a VA, that value is, this is VB, and this is the VC. Based on the problem, VC is known 16. And how about the VA? Because the voltage was here, the VA is 16. And it's a very simple way, right? And what is a VA? Another way to get the VA is VA is VB plus 18 here. Therefore, VB will be VA minus 18. So 60 minus 18 will be minus 2. We know that VB is minus 2. Then because of this node C, so this is node C, so we can rewrite the node equation here is because there is a VA, there is a VC, so current going to is to VA minus VC, to VA minus VC, and going to here plus 2 and 16 divided by R is going out here, so there will be minus, will be 0. So we adding the VA's 16 and VC was 16 minus 16 plus 2 minus R 16 is 0, that will be 0. So R 16 will be 2, therefore R is 8 ohm here. This is a way to calculate the R using the node equation, node voltage method here. So this is a wrap up. In this chapter, we're discussing how to make an equation. We have an electric circuit here, then we want to know the value of that. That means we need to know about the voltage or current. This is a kind of unknown variables. Then to get the values, we should make equations. Then we solve to get the values. Then we need to know how to make an equation here. The way to make an equation is two-way here. Node voltage equation. And another thing is mesh current equations. There's kind of the method to define these equations. Based on the result, you can get the voltage and current of electric circuit. There's a kind of very simple but very general the approach to analysis of electric circuit. This is not only this is not only the R circuit, but also capacitor and inductor energy storage circuit. And later we'll use the technique to apply to analysis the AC circuit. And then the time variable circuits. It's very important and very simple, very fundamental approach to see the electric circuit. You should solve many examples and many problem sets because you should familiar with the node voltage method and mesh current method.